I'm presenting a problem about using Sklearn's ridge regression model to predict house prices. We've got a model with a high R-squared, but I suspect it's overfitting due to many features that might be related to each other. The goal is to pick the best ways to improve the model's ability to predict prices for new houses, rather than just memorizing the training data. Think of it like this: a student who memorizes answers instead of understanding concepts. We want a model that understands. This option involves adjusting the alpha parameter in ridge regression. Alpha controls the strength of regularization, which helps prevent overfitting. Increasing alpha makes the model simpler by reducing the influence of individual features. It's like adding a penalty for having too many complex parts in a model. Decreasing alpha weakens the regularization, essentially giving the model more freedom to fit the training data closely. This might lead to better performance on the training data, but it also increases the risk of overfitting, which means poor performance on new data. Think of it like letting the student guess all the answers without studying. This leads to poor performance on the actual test. Adding more features isn't always a good idea. It could increase overfitting. We only want features that genuinely improve the model's predictive power. Adding irrelevant features to the model is like giving a student extra, unrelated material to study. It would likely distract and hurt their understanding of the core material. This involves reducing the number of features. Selecting only the most relevant features simplifies the model, reducing complexity and lowering the risk of overfitting. This is akin to a teacher focusing on the most important exam material and ignoring the extra or unnecessary details. This sets the stage. I'm working with a ridge regression model, predicting house prices and encountering overfitting. The model is too tailored to the existing data. Multicollinearity, where features are highly correlated, also makes things trickier. I need to determine what strategies can reduce overfitting. This is the core issue. Overfitting in a ridge regression model. Overfitting occurs when a model learns the training data too well, and performs poorly on unseen data. I'm presenting you with a machine learning problem. We're using ridge regression, a type of linear regression, to predict house prices. We've got a good R-squared score, but I suspect overfitting because we're using many features that might be related to each other. The goal is to pick the options that would improve the model's ability to generalize to new data and reduce overfitting. To solve this problem, I need to understand how the alpha hyperparameter and feature selection affect ridge regression's performance. Alpha controls how much we penalize large coefficients. Large coefficients suggest overfitting. Feature selection simplifies the model, so less data is needed. I'll consider how changes to alpha and the number of features affect how well the model generalizes to new, unseen data. This involves understanding how the alpha hyperparameter in ridge regression works. A higher alpha increases regularization, leading to smaller coefficients and thus reduced overfitting. Reducing the number of features simplifies the model, which helps generalization. I see this as the overall title for the quiz. We're tackling how to deal with overfitting in a ridge regression model. It's a common problem in machine learning, and ridge regression provides a great tool for addressing it. This sets the stage. We have a model with a high R-squared, which looks good at first glance. However, I suspect it's overfitting, performing very well on the training data but likely doing poorly on unseen data. That's the challenge we need to solve. This is a key concept. In ridge regression, regularization means adding a penalty to the model's complexity. A stronger penalty, larger alpha, forces the model's coefficients to be smaller, thus simplifying the model and making it less prone to overfitting. It's like adding a constraint to prevent the model from becoming too complex. This statement highlights the opposite effect. If I reduce regularization, smaller alpha, I allow the model to become more complex again. This can lead to overfitting because the model learns the training data too well and doesn't generalize well to new, unseen data. Increasing the alpha value directly increases regularization strength. I'm effectively making the model simpler and less prone to memorizing the training data. This leads to better generalization to unseen data. This would weaken the regularization. The model would be more complex and more likely to overfit. Adding more features can actually make the problem worse. Unless these features are truly relevant, I will likely increase model complexity and lead to overfitting. Feature selection helps. By removing less useful or redundant features, I simplify the model, preventing it from fitting noise in the data, and improve the model's ability to generalize. We're tackling a common machine learning problem: overfitting in a ridge regression model. Overfitting happens when your model learns the training data too well, performing great on it but poorly on new, unseen data. Think of it like memorizing the answers to a test instead of understanding the underlying concepts. A good model generalizes well to new data. That's our goal. This is a multiple-choice question designed to test your understanding of how to address overfitting in a ridge regression model. I'm going to present you with a few options, and your task is to select the best approaches to improve generalization and combat overfitting. This sets the stage. You have a ridge regression model predicting house prices. The R-squared score looks good, but you suspect overfitting, which is a common problem with many features that might be related: multicollinearity. We need to fix this to create a model that performs well on unseen data. Let's find the solutions. This is one solution to address overfitting. Increasing the alpha parameter increases the penalty for large coefficients in the model, which reduces the model's complexity and improves the generalization ability. It's a regularization technique. This option would worsen overfitting, as reducing alpha reduces regularization strength. Think of it as giving the model more freedom to fit the training data perfectly at the expense of its ability to do well on new data. Adding more features can increase the risk of overfitting, especially if those features are not relevant. A more complex model with more features can fit the training data exceptionally well but fail to generalize to new data. This is another effective strategy. By carefully selecting only the important features, we simplify the model, making it less prone to overfitting. I'm tackling the challenge of preventing overfitting in a ridge regression model, which is a type of linear regression that adds a penalty to the model's complexity to avoid overfitting. I'm assessing different strategies to improve how well the ridge regression model predicts new, unseen data by reducing overfitting, meaning it doesn't rely too much on the specifics of training data. Decreasing alpha weakens the penalty, which makes the model more complex and increases chances of overfitting. This is not what we want. Adding more features without careful selection can increase complexity and lead to overfitting, especially if the new features are irrelevant or redundant. Increasing alpha strengthens the penalty, which simplifies the model, helps prevent overfitting, and improves how well the model predicts unseen data. It's like adding a bit of caution to the model. Removing less important features simplifies the model, thus reducing its complexity, and helps mitigate overfitting. We're tackling the problem of overfitting in a ridge regression model. Overfitting happens when your model learns the training data too well, performing great on that data but poorly on new, unseen data. Think of it like memorizing the answers to a test instead of understanding the concepts. You'll ace that specific test but fail others. Ridge regression aims to prevent this. This question tests your understanding of how to make a ridge regression model better at predicting on new data. We're looking for actions that will prevent it from overfitting. Let's see what improves generalization. Decreasing alpha weakens the penalty that ridge regression uses to keep its coefficients small. This can actually make the model more prone to overfitting. Imagine loosening the reins on a horse. It might run faster, but it might also run wild. Increasing alpha strengthens the penalty, forcing the coefficients to be smaller. This makes the model simpler and less likely to overfit. It's like tightening the reins on that horse. You'll get a more controlled, steady ride. Adding more features without careful selection can lead to overfitting. You're giving the model more chances to memorize noise instead of the underlying patterns. It's like adding unnecessary details to a story. You might confuse the reader. Removing irrelevant or redundant features simplifies the model and improves generalization. Think of it like editing a story, removing unnecessary details to enhance clarity. The more focused the model, the better it predicts. The best approach is to combine increased regularization, A, with feature selection, D. It is like taking care of overfitting from both ends. Regularize and minimize number of features. Nice work. These two options work together to address overfitting. Increasing alpha and reducing the feature set simplify the model, improving its ability to generalize to new data. Remember this combination? I'm tackling a problem about how to make a ridge regression model better at predicting house prices. The model is currently overfitting, meaning it's too closely tied to the training data and won't generalize well to new houses. We need to improve its ability to predict accurately on unseen data. Specifically, I'm dealing with a ridge regression model that's overfitting. That means it's performing really well on the data I used to train it, but I suspect it won't do as well on new, unseen data. This is a common issue in machine learning. The goal is to improve the model's ability to generalize. I need to identify strategies to reduce overfitting and enhance the model's predictive power on new data. The options involve adjusting a key parameter in the model and modifying the features used. One potential solution is to increase the alpha value. Alpha controls the strength of regularization in ridge regression. A higher alpha means stronger regularization, making the model simpler and less likely to overfit. Think of it like adding a penalty for overly complex solutions. Conversely, decreasing alpha weakens regularization. This could lead to a more complex model that fits the training data too closely but generalizes poorly. Adding more features isn't always a good idea. It could introduce noise or redundancy, potentially increasing complexity and overfitting. More features don't automatically mean a better model. Feature selection is often key to building robust models. By removing less important or redundant features, I can simplify the model, potentially preventing overfitting. This focuses the model on the most relevant aspects of the data. The best approach is to address overfitting in this scenario or increasing alpha for stronger regularization and performing feature selection to simplify the model and improve generalization.